Hello, everyone. I greet you with the Islamic salutation, Assalamu alaikum, peace be upon you. Welcome to the Islamic Heritage Month event hosted by the Ahmadiyya Muslim Jamaat Canada. We're excited to have you join us to mark this momentous occasion. As you may know, Islamic History Month recognizes the significant role that Muslim communities play in Canadian society and highlights the extraordinary contributions of Muslims to various facets of human life. The theme of our program today specifically is Muslims' contributions to science. Now, during the course of this program, we have an exciting Kahoot game which will be played, so I hope you're all ready for some competition. We have a series of presentations today, and I'll be asking one quiz question after each presentation. So I hope you're all staying engaged and paying attention, as the top 3 winners will be getting special prizes. And I'll request everyone who wants to participate in the Kahoot game to please have your devices ready and connected. Also, this is a note for the teachers that during the course of the program, if there are any questions about the presentations from yourself or your students, please refer to the Google Docs link, which was sent to your email. You can submit your questions there and we'll do our best to answer them during the question and answer session. Without further ado, let's get our program started. As is customary, we'll be commencing our program with the recitation of the Holy Quran, followed by its English translation. And for that, I would like to request Imam Basil Raza Bhatt.
Assalamu alaikum wa rahmatullahi wa barakatuhu. May the peace, mercy, and blessings of Allah be upon you all. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. ولله ملك السماوات والأرض والله على كل شيء قدير. إن في خلق السماوات والأرض واختلاف الليل والنهار لآيات لأولي الألباب. The English rendering of the verses just presented to you, selected from chapter 2, that is chapter Ali Imran, verses 190 and 191 is as follows. In the name of Allah, the most gracious, the ever merciful. And to Allah belongs the kingdom of the heavens and the earth, and Allah has power over all things. Surely in the creation of the heavens and the earth, and in the alternation of the night and the day, there are indeed signs for people of understanding. Thank you very much. Jazakumullah ahsan al-jaza.
Thank you, Imam, for that beautiful recitation. We'll now be watching a video by Al Jazeera on the contributions of early Muslim scientists to the field of astronomy.
Understanding the universe and the vastness of space is at the forefront of physics and astronomy research today. Everything from white dwarfs and red giants to neutron stars and black holes. But imagine trying to make sense of the cosmos before telescopes were even invented. Well, between the 9th and 14th centuries, scholars from the Islamic world consolidated and refined the astronomy of earlier civilizations and came up with ideas that have deeply influenced astronomy right through to the present day. I'm Jamal Khalili, a British professor of physics, but born in Baghdad, and I'll be taking a look at modern-day astronomy and navigation and exploring the contribution made to these fields by the scientists of the Golden Age. As well as navigation, astronomy was also important for the measurement of time. For example, the Islamic calendar is a lunar calendar where the months are determined by the phases of the moon. During the Golden Age, astronomers studied the movements of the moon to predict the calendar more accurately. The 12 months making up the Islamic year are shorter than the Earth's orbit of the sun. So, Islamic months and religious observances like Ramadan move from year to year. This app on my tablet allows me to scan the night sky and identify the stars and planets. It's the modern-day equivalent of the ancient star chart, known in Arabic as a Zij. Now, in the early 9th century, the Abbasid Caliph al-Ma'mun, the ruler of the powerful Islamic empire, was a man obsessed with scholarship and learning. And he commissioned a group of astronomers to produce a new Zij. Now, they already had the astronomical tables of the ancient Greeks, but they were tasked with improving on them, correcting errors and making more accurate measurements. They produced a new star chart that became known as al-Zij al-Mumtahan, or the verified tables. One of the most important observatories of the Golden Age was called the Maragha Observatory, built in 1259 in Persia for the great astronomer Al-Tusi. When the Mongols invaded, they captured the mountain fort of Alamut, where Al-Tusi worked. Not only did he convince the Mongol general Holako, or Heluga Khan, to spare his life, he convinced him to build him a new observatory. In return, Al-Tusi promised to provide the general with his astrological charts so that he'd know what day to go to battle. The Maragha Observatory became the most important of its day and a great hub for international scientific collaboration. The early 9th century Abbasid Caliph al-Ma'mun wanted to improve on this estimate, so he commanded a group of astronomers to repeat it. However, the method involved them trudging through the desert for over 100 kilometers, a method that was prone to error. 200 years later, in the 11th century, the Persian astronomer al-Biruni came up with a much easier and more accurate method of estimating the size of the Earth. But it did involve climbing a mountain that looked out over the horizon. Al-Biruni was a prolific scholar who even debated about whether the Earth was moving. He explained how to work out the size of the Earth in his book on the determination of the coordinates of cities. First, he measured the mountain's height. Al-Biruni then had to climb to the top of the mountain, and armed with an astrolabe and a plumb line, he then measured the angle of dip from the horizontal down to the distant horizon. Now, this was just half a degree, so he had to be incredibly precise. But armed with this information, he could then use some more clever geometry to calculate the circumference of the Earth. Let me show you. Imagine this circle is the Earth, and this is Biruni's mountain. Now, looking across horizontally, he measured the angle of dip to the horizon, this angle here. Now, if you draw two lines, one through to the center of the Earth from the mountain and the other from where the line touches the horizon, you end up with a right-angled triangle. Now, Biruni knew that the angle he'd measured is the same as this angle inside the Earth. Armed with these two pieces of information, the the size of this angle and the height of the mountain, he was able to use geometry to work out the radius of the Earth. Multiplying this number by 2 pi gives him the complete circumference. He got to within 1% of the accurate value we know today, about 40,000 kilometers, which is pretty remarkable. It's easy to think that astronomy went to sleep after the ancient Greeks and didn't wake up again until Copernicus in the 15th century. But developments in astronomy continued in Spain, the Middle East and Central Asia throughout medieval times. The Renaissance scientists of Europe who created modern astronomy were building on the work of people like al-Biruni and al-Tusi, who in turn were building on the knowledge passed over to them from earlier civilizations. Today, in the 21st century, international teams of scientists are still looking to the stars and mapping the cosmos using ever larger telescopes. But we must remember that they owe a huge debt of gratitude to those astronomers of the Moraga Observatory.
All right, that was quite remarkable to see how the early scientists of the Golden Age were able to make these kind of astronomical discoveries with such accuracy. All right, so it's time for our first Kahoot question as promised. So I'm going to ask everyone to please get your devices ready. We're going to give a little bit of a buffer room here to get your devices ready. And we're going to get our first question underway. All right, so the first question is, the 11th century astronomer al-Biruni accurately calculated the what? Earth's circumference, Earth's radius, or all of the above? All right, so all of the above was the correct answer, and we're going to move on to our next segment, which is an educational tableau depicting early Muslim scientists. Let's take a look.
दीन अहमद का जो आज सालार है, तीर हाथों में उसके न तलवार है, साथ फौजों की कोई न यलगार है.
Known in the West as Albategnius, I, al-Battani, wrote the Sabian Tables, which was a very influential work for centuries. My work also included the timings of the new moons, calculation of the length of the solar and sidereal year, the prediction of eclipses, and the phenomenon of parallax. I also popularized, if not discovered, the first notions of trigonometric ratios used today, and made serious alterations to Ptolemy's theories, which at the time had been used as the important discovery that the motion of the solar apogee, or the position of the sun among the stars at the time of its greatest distance from Earth, was what it had been in the time of Ptolemy. The Greek astronomer placed the sun at longitude 65 degrees, but I found it at longitude 82 degrees. This discrepancy was a distance too great to be accounted for by any inaccuracy of measurement. But today we know it is because the solar system is moving through space. Then, though, it was believed that the Earth was the center of the universe, so this conclusion could not be made.
Allow me to introduce myself. I am Nasiruddin al-Tusi. I was born in 1201 and I lived in Iran. Some say I was one of the greatest scientists of medieval Islam. Well, there's no surprise to that, of course. Why, I was a Persian polymath, theologian, philosopher, scientist, and physician. However, I was best known as a mathematician and an astronomer. I also wrote books on the topics of math, engineering, prose, and mysticism, therefore becoming a well-published author as well. There is a crater 30 miles in the diameter named after me. I was a minister to Hulagu Khan, Ilkhanid ruler of Persia. I was put in charge of the observatory installed at Moraga by Hulagu and in preparing the Ilkhanid tables and catalog of fixed stars which remained in use for several centuries throughout the world, from China to Western Europe. Even Nicholas Copernicus, the 15th century Polish astronomer, who was famous for introducing the sun-centered theory of the solar system, which marked the beginning of modern astronomy, drew inspiration from mathematical devices discovered by me and fellow Muslims before him. The only difference between the two models of the solar system was that Muslims' Earth was fixed in space, whereas his had it orbiting around the sun.
Greetings. It's a pleasure to meet you. My name is Maryam al-Ijli al-Astulabi, and I live in the 10th century. I, like my father before me, spent all my life studying astronomy and making astrolabes. But what is an astrolabe, I hear you ask? Well, think of it as a sophisticated navigation device, but like a computer. It had a wide range of uses. It could tell time during the day, tell the direction of Mecca in the east, and it could even pinpoint locations of various stars. Astronomers in particular cherished and used them extensively. For we were all fascinated by the heavens for its deep reference in the Holy Quran. So much so that scholars in early Muslim civilizations established astronomy as a new and exciting science in its own right. A science that could help us discover the secrets of our universe. What is clear is the ideas and technology that blossomed in my time helped shape the thinking of many that followed. Now the question is, how would one of my astrolabes look like in one of your cars?
Founder of Indology, father of comparative religion, father of modern geodesy, and first anthropologist. Who do all these titles belong to? Well, me. I am al-Biruni, and I was born in 973 AD in Biruni, Uzbekistan. I was an Iranian scholar and polymath in the Islamic Golden Age. I have served more than 6 princes. I was very well versed in physics, mathematics, astronomy, and natural sciences. I also distinguished myself as a historian, chronologist, and linguist. I studied almost all the sciences of my day and was rewarded abundantly for my tireless research in many fields of knowledge. Royalty and other powerful elements in society funded my research and sought me with specific projects in mind. Spherical geometry was also needed when Muslims were finding the Qibla, which is the direction of Mecca, which we prayed toward and which our mosques faced. It was me who worked this out from any location on the globe. I was literally interested in everything. I sometimes got referred to as the Leonardo da Vinci of my day.
My name is Taqiyuddin. I was an Ottoman polymath born in Damascus, Syria, active in Cairo and Istanbul. I was the author of more than 90 books on a wide variety of subjects: astronomy, clocks, engineering, mathematics, mechanics, optics, and natural philosophy. I invented the steam turbine. I am best known for the Constantinople Observatory of Taqiyuddin, which I founded in 1577. I am famous for using a sextant that used the 5th type of quadrant. You could use these quadrants to align with the celestial bodies and read off the angle between a star. However, there were several Muslim astronomers other than myself who worked extensively on improving the designs of the sextants and quadrants.
दीन अहमद का जो आज सालार है तीर.
All right, so that was a great tableau by these very talented Muslim boys and girls depicting scientists from the Islamic Golden Age. Taqiyuddin wrote more than how many books? 90 books, 50 books, or 10 books? All right, so the correct answer was 90 books, and that's great. Everybody seems like they're paying attention now. Good stuff. All right, well, now I'd like to welcome Jenna Hintz. Jenna is an outreach coordinator at the Royal Astronomical Society of Canada. Jenna has been in charge of national outreach at the Royal Astronomical Society of Canada for 3 years. Jenna.
Thank you so much for the introduction. And today I'm going to talk a little bit about some of the planets that you can see if you head outside, even this evening, depending on whether or not there are clouds. So we're going to focus on 2 planets today, and that's Jupiter and Saturn. They're really bright planets, and they're pretty easy to see even if you live in a city. So they are up for another couple months, and I'm going to show you how you can find them by sharing my screen here and looking at our view this evening. This is from Toronto. This is our view tonight around 7 o'clock of the sky. And if you look down towards the south, you're going to be able to see 2 really bright objects fairly close to each other. The moon's going to be rising over here soon. And you'll also be able to see this planet here, which is not what we're going to talk about today, but that is Venus, and it's only up right before the sunset. If you look at these two bright objects, they're going to be the brightest things you can see facing south. The one on the left here is Jupiter. It's brighter of the two. And then the one on the right is Saturn. And so if you take a look for those two tonight, Saturn is quite a bit dimmer, but you'll be able to see them even if you're in a city. They're really, really bright. So even though there's lights from the city, they shine right through, and you can see them yourself. Now, normally what I would do is pull out my telescope and let you look at them. But of course it is daytime. So we can't, they're a little bit harder to find in the daytime. So what I'm going to do instead is share the views of these planets from my telescope. And so what you'll be able to see here, this is Jupiter through my scope. It's one of my favorite views through a telescope. It's really cool. I don't know if you can see here, and I'm going to zoom in a little bit. You can see this dark band right there. That dark band is one of the cloud bands on Jupiter. So Jupiter is a really big planet with a lot going on. It's the second biggest planet, it is the largest planet in our solar system, the second biggest object in our solar system. The sun is the only thing that's bigger than Jupiter. And it's also probably the oldest planet in our solar system as well, probably formed around the same time as the sun. And it's made of the same stuff as the sun. If you're wondering why I'm jumping around with my telescope here, it's because, unfortunately, the Earth spins. Well, not unfortunately, it's pretty great. We get days. But as the Earth spins, the sky moves a little bit. It's hard to tell, but it moves throughout the night. And this is how much it moves as my telescope is pointing at it. You'll see Jupiter drifting across the screen. That's the Earth turning, and us and my scope not accounting for that turn of the Earth. So you'll see it jumping around a little bit. So those cloud bands, I don't know if you know this, you probably do, one of the most important or most interesting parts of Jupiter is this spot called the Great Red Spot. And the Great Red Spot is the biggest storm in the entire solar system and also the biggest storm on Jupiter. It's huge. You can't see it in this video. It's only up every once in a while. Jupiter turns just like Earth does. But when it's up, you can see it. It is about just a little bit bigger than Earth, actually. So Earth would fit inside of this one big storm on Jupiter. If you think of something like a hurricane that happens further down south, storms like that, they seem really big. This storm is the size of Earth. It would cover our entire planet. And it actually even used to be bigger. It used to be about 3 times the size of Earth, at least across. But it's been getting smaller, and we know it's existed for at least the past 400 years or so. So it's a very long running storm and a very, very big storm. Jupiter is also really cool because since it's made of the same stuff as the sun, if it had gotten bigger, if it had been about 13 times bigger, it itself would have actually been a star, just like our sun, which is kind of cool. It isn't. It's still small, so it's still considered a planet. And the other really cool thing, too, is that it's possible it may have been closer to the sun around where we are earlier in its life, but we don't know for sure because we weren't here to look at it back at that time. I increased the brightness here so that you can see something kind of cool. Do you see these little dots? Those little dots are 4 of Jupiter's brightest moons. They're harder to see when you can actually see the detail on Jupiter because Jupiter itself is really bright. They're still there, it's just they're harder to see. And so by turning up that brightness, you get a little bit of an extra view. In case anyone's curious, the clouds on Jupiter look a little like orangey brown. And the reason that they look that way is because they're mostly made of an element called ammonia, but when the storms surge, and that's what you're seeing is these clouds rolling through, it brings elements and things up from the core of Jupiter to the surface, and it changes that color to kind of a brown color. And it's thought that the white storms, you can see there's white bands above the darker bands. The white bands are colder storms, and the darker bands are hotter storms. That's what they think. For those who are curious, the core of Jupiter is also, Jupiter's mostly gas. It's one of these 2 planets, Jupiter and Saturn, are often called the gas giants because they are, this barely needs to be said, they are giant and they are made of gas. But the core of Jupiter is actually metallic and rocky and icy. So there's a hard core, but for the most part, they're really puffy, gassy planets. I'm gonna be wary of time. I'm gonna just quickly switch over to our next favorite planet. This is one of my favorites in general. Oh, that's there we go. This is, as I'm sure you can tell, Saturn. There we go. Saturn. This is way closer up, and you'll see a clearer view in a second. There it is. This is Saturn, the planet with the rings. It is the dimmer of the two, so Jupiter's a little bit brighter, Saturn's a little bit dimmer. Part of that is that it's a little bit smaller, and the other part is that it's much further away. So Jupiter is about 5 times the distance that we are from the sun out, and then Saturn is 12 times the distance, so it's way further. But it's one of my favorite planets to look at because it's got those beautiful rings. So you can see the core of the planet here and the rings around it. The rings were likely stuff caught by the planet's gravity from out in the solar system, things like small moons, asteroids, comets, that were torn apart by Saturn's gravity to form those rings. There are a few little tiny moons that are inside of the rings as well. So there's one little gap that has a moon that's cleared a path in the rings. And I have some good news. Here's a different view where you get a little bit more clarity. This was a better night, so a little bit more, the atmosphere was nice and calm. And what you can see, if you look closely, this is one of my favorite views. Do you see that little dark spot back here? That dark spot is caused because of the light that's shining on Saturn. The sun, at this point, Saturn we from where we're observing and the sun are quite far away from each other. And so Saturn's body, Saturn's planet, casts a shadow on the rings behind it. And so you can see that little bit of a shadow here, which to me just makes this feel so much more real. And like you're actually, like, it just makes it feel so cool to be looking at something so far away that's 3-dimensional. It was so cool. Saturn has some really fast winds as well. So it's also made of gas, and its winds can get up to 1,800 kilometers an hour, which is crazy. That's traveling half a kilometer in 1 second. So it's very fast. The other thing, it's bad news, but also makes us feel very special. The rings have not been around forever, and they won't be around forever. They are slowly falling, well, actually quickly falling into Saturn. And so over the next about 100 to 300 million years, the rings will disappear because they'll fall back into Saturn. The other thing, I don't know if we can see it in this video. We haven't seen it yet. I have to turn up the brightness to be able to see it, but I was so distracted by how bright and beautiful Saturn was. Saturn actually does have a moon that you can see through a telescope called Titan. And I don't think we'll be able to see it. It's the second largest moon in the solar system, and it has its own atmosphere, just like Earth. Well, close to Earth. Earth's atmosphere is mostly made of nice stuff like oxygen and water. Titan's atmosphere is made of something called methane. So it's very cloudy, but it's not something that humans can breathe. The other kind of cool thing about Titan is that it actually has liquid on the surface. The way that we have lakes, which are made of water, Titan has lakes that are made of methane. It's the only other body in the solar system that we know of that has liquid on the surface. Its core is also quite dense. It has metal in the core as well. This is by far my favorite thing to observe. I'm going to wrap up because I think we're running out of time, but it is so cool. The coolest thing about this, in my opinion, is that this planet is also very light, which is weird. It's big, but it's quite light. So it's like picking up styrofoam almost. And if you had a giant bathtub, if you had a bathtub large enough to fit Saturn, if you threw Saturn in it, Saturn would float on the surface. That's how light it is. So I hope that by taking a look at these videos through a telescope, I hope that you're inspired to get outside and discover the night sky for yourself. Next time that you get a clear night, see if you can spot them. They're going to be to the south. If you're living in Ontario, if you face towards the lake, I say if you're living in Ontario, if you're living on the south part of Ontario, if you face towards the lake, you should be able to see these two planets.
Perfect. Thank you so much. the very insightful presentation, and now we want to test the audience's knowledge of your presentation. So let's head back to the Kahoot. All right, so it's time for the quiz again. Everyone get their devices ready. The question is, how big is Jupiter's great red spot right now? So let's test your knowledge of Janahin's very insightful presentation. So that smaller than the moon, a bit bigger than the Earth, 3 times the size of Earth. And the answer is a bit bigger than Earth, and that's great. It seems that everybody's following along and staying engaged. Perfect. So we're gonna now move on to the next segment. We're gonna be watching a video where young Muslim boys and girls partake in an interesting stargazing activity. Let's take a look.
दीन अहमद का जो आज सालार है तीर हाथों में उसके
1, 2, 3, Assalamualaikum! Walaikum salam everyone.
है इब्न मंसूर की एक ललकार है दीन अहमद का जो आज सालार है तीर हाथों में उसके न तलवार है
Science about things out of Earth's atmosphere.
That's right. And what is outside of the Earth's atmosphere? What are things that are outside of the Earth's atmosphere? Summer.
Stars and
Planets. Go ahead, Urva.
The galaxy.
The galaxy.
दीन अहमद का जो आज सालार है तीर हाथों में
If we see this light that's coming here, let's imagine this was the sun. Now, right now, it is almost 8 o'clock. We like the shadow to go to 8. And you place it down right there. That shows that it's 8 o'clock right now. In an hour from now, you will see, when you come and look at the sundial, if you leave it right here on this table with this light on, you will see it will be 9. The shadow will be at the 9.
दीन अहमद का जो आज सालार है तीर हाथों
Imagine these are the stars, and these here are what we're going to make the shapes out of when we join the constellations. I want each of you guys to make a constellation with the marshmallows and the toothpicks. Can you guys do that? Yeah. Okay, be creative, and maybe if you know some constellations, make them. Okay, go ahead.
दीन अहमद का जो आज सालार है तीर हाथों
Look at the moon. It looks smooth to us. It's a little crescent moon, I know, but looking at it, it looks like it's smooth. It's smooth. But when you look at it up close, it has craters. It's an impact on the moon when there's something hard or an asteroid or anything like a meteorite that comes in and it impacts the moon. It leaves a big indentation. We are going to do a demonstration on how these asteroids or meteorites hit the moon's surface. So we are going to imagine that this is the moon's surface. And I'm going to give each one of you a marble. Okay, here. Each one of you is going to get a marble. Please drop one as high as you want. See the indentation that's created a hole right in there. And you see all the minerals that have come out, and then they have showed, that's exactly what it shows on the moon. So that doesn't, you can see this one did not hit as hard. It looks like Isa's hit really hard. But that's just an example of how the indentations in the moon are.
दीन अहमद का जो आज सालार है
do is take a step up here and you're going to look at the moon. We're looking at a close-up of the moon. So look at look down and look at the craters on the moon. Tika? You see it? You can see the moon. You see how the surface of the moon is really rough and you see all the craters on the moon? Do you see that? And it's you see it? That's the moon. That's the surface of the moon. And you see how it's not that clear, because it's a crescent moon right now. Is it interesting?
Yeah.
So the surface from the moon, when you see from here, you see it's so smooth. But when you look through a telescope, you could see how rough and how many craters are on the surface. Okay, great.
I'm an astronaut joke for you.
What's an astronaut joke?
How do you, if an astronaut is sad, how do you make it happy?
If an astronaut is sad, how do you make it happy?
You give it some space.
Oh, I like that.
तीन अहमद का जो आज सालार है तीर हाथों में उसके न तलवार है
Look at any part of the sky and this will tell you the name of the star, the constellation it's making, and everything about it. Like you can even see planets on it.
तीन अहमद का जो आज सालार है तीर हाथों में उसके न तलवार है साथ फौजों की.
All right, so it seems that some of these young boys and girls will definitely be future scientists. So it's now time for our Kahoot question on this presentation. The surface of the moon is it smooth, indented, and full of craters, or full of life? And the answer is correct, indented and full of craters. 100 people got that correct, so that's great. All right, so we're gonna now be hearing from Chris Vaughn. Chris is an award-winning astronomer and an earth scientist with a lifelong passion for visual observing. Chris, thanks for joining us.
Thanks for having me this morning. It's an honor to be here. I'm very delighted to be able to share my passion for astronomy with everybody watching. So what I'm going to do for the next few minutes is tour everyone through the constellation of Pegasus. Pegasus is a terrific constellation. It's in one of the oldest but largest constellations in the night sky. And much as Jenna pointed out to you, that you can head out and find Jupiter and Saturn and Venus in the evening sky, if you wait for it to get a little bit darker, and instead of facing south, face a little bit towards the east, and let the sun go down a little bit more. I'll just let the sky get a little bit darker here, and more of the stars to come out. You can see there are a few bright stars in the sky. I'm going to now join the stars into constellations by connecting the dots. And you can see that there's a constellation here called Pegasus, which is labeled in the middle. And Pegasus is actually the winged horse from Greek mythology. But as is true for most constellations in the sky, even though they have Greek or Latin names, their star names come from the Arabic scholars, some of whom we saw in the earlier tableau. And so what I'm going to do is I'm going to show you how to find Pegasus, and then I'm going to tour you through the stars so you can see some of the interesting aspects of the constellation. So if you face east around, this is around a little bit after 7 o'clock. Let me just bring it up a little bit later so we can get the sky a little bit darker. So after 7:30, maybe 8 o'clock in the evening sky for the next clear night, head outside, face east. You can see that up here I've got a green letter Z. The green letter Z represents the sky straight over your head. And so Pegasus is sitting about halfway up the sky from the horizon to the zenith. And you can confirm that you've got the right location by looking for the bright star Vega right above, near overhead. And then to the upper left of Pegasus, you've got the W of Cassiopeia. Now Pegasus, I'll just put the artwork on here. Pegasus actually is only half the horse. You can see there's a big square that represents his wings. Then he's got a chain of stars marking his eye and his nose for his head. And then there are a couple of chains of stars marking his front legs, but the back of half of him is missing. And we think that's because the ancient Phoenicians who envisioned this constellation were actually comparing him to the carved wooden horses that they would mount on the front of their ships. And so they didn't need the back half. And in fact, you can see that the back half, where the horse should be, is occupied by this constellation of Pisces, the fishes. And also below Pegasus's head, you've got Aquarius, the water bearer. And so that's sort of extra evidence that it was associated with the ships and with sailing. Now, let me just zoom in a little bit more. You're going to notice that when you head out that you're going to find this big square of stars made of 4 stars, but actually the square is usually, when we see it, is usually tilted with one edge facing down. So it's more like a diamond, perhaps a baseball diamond effect, if you like. And if you make a fist and hold it out at arm's length and close one of your eyes and hold your fist up to the sky, it'll cover about 20 degrees of the sky. And you'll find out if you do this with Pegasus that 2 of your fists will cross from one edge of the diamond to the other edge of the diamond. And you'll probably notice that the middle of the diamond looks mostly empty, but you can see that there are a couple of brighter stars off-centered from the middle of the constellation. Now, even though the Greeks saw this square of stars as the wings of Pegasus, the ancient Arab astronomers actually saw this square as a water vessel or perhaps a water well. And what they would do is they would take a water skin, they would lash sticks across the mouth of the water skin to hold it open, and then dip it into the well to get water. And the little stars in the middle of the square would represent the place where the sticks were lashed together, were crossed together. So let me just tour you through a couple of the stars that are interesting. The bottom of the square, we have the star Al-Janib. And Al-Janib comes from the Arabic expression Al-Janb or Al-Janib, which means the flank of the horse. And that star is about 350 light years away from Earth, so that light has been traveling for 350 years to get here. But it's actually a much brighter star than our own sun. It's about 4,000 times brighter than our sun. If you look to the right-hand corner of the diamond, you'll see the star Markab. Markab, it comes from an expression that means the saddle of the horse. And this star is a little bit brighter than Al-Janib, but it's much closer. It's about half as far away. In some star labels, this star was named Matan al-Faras, which means the horse's shoulder. Now, from there, you can start stretching off to the right and look for the stars that make the neck of the horse, including the star Homam, which comes from the expression Sa'ad al-Hamam, or man of high spirit. Then you can see another star named Biham. Biham is named for the lucky stars of the young beasts. And these have about the same brightness. And look for a little star a little bit further along called Al-Fama Faras, which is the mouth of the horse. But actually, the true mouth of the horse, from our point of view, is this star Enif. Enif is a little bit higher up. And you might notice that Enif is a little bit of an orange color compared to the other stars in the constellation. It comes from an expression Alanf, which means the nose of the horse. This star is actually a low-temperature orange supergiant star. It's not quite big enough, perhaps, to explode in a supernova, but one day it might do that. But if it were to trade places with our sun, that star would be 80 times bigger than our sun in the sky. That's such a huge star. Now, if you have binoculars and you can make a line that starts at Biham and goes up through Enif and carries on a little bit further, you'll find a little gray fuzzy patch in the sky. I'll just zoom in on here. And this is actually a globular star cluster. It's called Messier 15. And it's composed of perhaps 100,000 stars all bound together by their mutual gravity and orbiting the outside of our galaxy's core, the Milky Way's core. And it actually maybe sort of resembles a dandelion flower or a dandelion head that the horse is nibbling on. So you just remember to make that line and continue past NF, and you can find that dandelion, that globular cluster. At the top of the square, we have the star Shiat. And Shiat comes from an expression that means the foreleg. And then we have two of the horse's legs extending from the top of the square from Shiat. So the two Pegasus's front legs. So the first leg we have here is the star Matar. So you head up from Shiat, you can find Matar. Matar comes from Al-Sahad al-Matar, the lucky star of rain. And if you carry on looking beyond it to the tip of the horse's leg, the hoof, and use binoculars, you'll notice that this star named Pi, because the smaller stars don't have proper names, they have Greek letters or numbers, is actually a double star. You can see that there are two close together stars in your binoculars if you look closely. Heading on the other leg, we have two stars. We have Saddlebari and Saddlenazi. So Saddlebari means the auspicious star of the splendid one, and Saddlenazi is comes from the auspicious star of the camel. So that's kind of represents the knee of the horse. From there, you can then head up to the upper right, look for the little fainter star named Iota Pegasi, and then a little bit further on, you'll find the other hoof, that's Kappa. So you can trace out the horse's legs that way. Now, finishing up the square, we come to Alpheratz, but Alpheratz is actually a star that's part of another constellation. It's shared with the constellation of Andromeda, the princess, and it represents her head. So that's a story for another night. Now, looking at the square, I mentioned the two little stars in the middle. Those represent the crossed sticks holding the water skin open. You can also notice that there's a faint star that should be visible with your eyes, sitting about here, so it's about halfway along this upper right edge of the square and a little bit outside. It's about a thumb's width outside this line. And that star's name is 51 Pegasi, or 51 Peg. Again, it's not bright enough to have its own proper name. But what's fascinating about this star, it was the first star that we ever knew had a planet orbiting it, other than our own solar system's planets. And that was discovered in 1995 by astronomers. That planet is about half the size of Jupiter, and it orbits so close to the star that it is able to orbit the star every 4 days or so. So it's closer even than the orbit of Mercury in our solar system. So it's called, what we call is a hot Jupiter. Now, originally that star was nicknamed Bellerophon after the rider from Greek mythology that first rode on Pegasus's back. But astronomers have since renamed that star, that exoplanet orbiting that star, to Dimidium. Dimidium is a Latin word that means half, so that represents the fact that it's half the size of Jupiter. So just to finish up, a couple more things that you might have been curious about what these stars' names were. So these two little stars are named Sol and Alcarab, and those come from expressions that mean leather bucket and the bucket rope. So there's your tour of Pegasus. I hope you'll go out on the next clear night and look at that fascinating constellation.
Perfect. Thank you, Chris, so much for that intriguing presentation on Pegasus and astronomy. What everyday object did the Great Square of Pegasus represent to the ancient Arabs? Al-Dal, the water bucket, Danab al-Asad, tail of the lion, or Aquarius, the water bear? And the correct answer is Al-Dal, the water bucket. And most people got that correct. So now we have a presentation by Dr. Munazza Alam. Dr. Alam is a Muslim American, an astronomer, and National Geographic young explorer. She studies the atmosphere of exoplanets, or planets outside of the solar system, using data from the Hubble Space Technology.
Assalamu alaikum, everyone. For those of you who may not know, this is a Muslim greeting which means peace and blessings of God be upon you. It's simply another way to say hello. Thank you so much for listening to this presentation. And I'm sorry that I couldn't join the event live today. So before I get started, I would like to take a moment to introduce myself. My name is Munazza Alam, and I'm an astronomer as well as a Muslim American. I grew up in New York City, where I couldn't really see the stars. This is a picture of the New York City skyline, and we can see that the city lights outshine the stars, so you can only really see a handful of stars at a time at best. But when I finally did see a beautiful dark night sky, it looked something like this. And I was hooked. This was an absolutely breathtaking sight for me. And I knew at that moment that I wanted to be an astronomer. Being an astronomer is really fun because I get to use telescopes to observe stars and planets. And the telescopes that I use aren't like the ones that you might set up in your backyard. They are huge, about the size of a school bus even. To get a sense of just how big these telescopes are, here's a picture of me standing in front of a telescope in Chile in South America that I use. Look how massive that telescope is. I love being an astronomer because it means that I can constantly learn new things about our universe. one of the things that I've learned about is the lunar calendar, which I'm going to tell you a little bit about today. But before we get started, let's talk about calendars in general. We know what a calendar is. It's a way to keep track of time by assigning dates. And we break down a year into months, and each month into days. When I say calendar, you're probably thinking of a calendar that starts in January and ends in December. This is a calendar in which we've split the year into 12 months, and where each month is 30 or 31 days long, with, of course, the exception of February, which is 28 or 29 days long. This calendar that we're thinking of is actually what we call a solar calendar, because it is based on the Earth's position in its orbit around the sun. The year from January 1st to December 31st is 365 days long. That corresponds to the amount of time that it takes the planet Earth to go around the sun. And during this year, we experience 4 seasons: winter, spring, summer, and fall. And these 4 seasons correspond to where in its orbit around the sun the Earth is and how it's tilted relative to the sun. Summer is a season when the Earth is tilted a little more towards the sun, so we have hotter weather. And in the colder winter months, the Earth is tilted away from the sun. But this isn't the only calendar system that exists. Another type of calendar is the lunar calendar. The lunar calendar is a way to keep track of time and dates based on the phases of the moon. When you look up at the night sky, you may see a full moon shining bright like the one in the middle of this image, or maybe you might see a crescent moon like the one on the left here. But we only have one moon orbiting around the Earth. So why does this moon have different shapes? The answer is that the moon looks different to us here on Earth depending on where in its orbit around the Earth the moon is. The moon orbits around the Earth once every 29.5 days. That's how long a lunar month is. And the different shapes of the moon that we see are the different phases of the moon throughout the lunar month. A lunar month starts with the new moon. That's the first lunar phase. The new moon is a barely there crescent, very faint. And over the first half of the month, we'll see the moon grow into a full moon. And when the moon is growing like this every night, we say that the moon is waxing. And then after the full moon, which happens in the middle of the lunar month, we'll notice that the moon starts becoming smaller again for the second half of the month. And when the moon is getting smaller every night towards the end of the lunar month, we say that the moon is waning. The moon will become smaller and smaller at the end of the month until it's the new moon again, which signals the beginning of the next lunar month. There are many examples of lunar calendars out there. There's the Hebrew lunar calendar, the Chinese lunar calendar, and the Islamic lunar calendar. In fact, lunar calendars have been used for thousands of years. Historians actually think that the ancient Sumerian civilization, one of the oldest civilizations in the world, invented the lunar calendar. Now, if we compare the lunar calendar with the solar calendar, both are 12 months long, but there's one key difference. And that is that the lunar year is about 10 or 11 days shorter than the solar year. The lunar year is shorter than the solar year because a lunar month is about a day shorter than a solar month. So the months of the lunar year can occur in different seasons of the solar year because the months of the lunar year kind of drift into different seasons since there is a gap of 10 or 11 days between the lunar and the solar years. So when I say that the months of the lunar year can occur in different seasons, one example of this is the Muslim holiday Eid. Eid is based on dates in the lunar calendar, and Eid occurs on the same dates of the Islamic lunar calendar every year, but Eid can be in the summer or the winter or the fall or the spring. It just depends on how the lunar calendar is aligned with the solar calendar that year. And we determine what day Eid is on by looking for the new moon. But depending on where in the world you are, you may see the new moon earlier or later than others. That's why Eid is sometimes celebrated on different days across the world. So now that you've learned a little bit about the lunar calendar, I have 2 quiz questions for you. Are you ready for them? 1. What is a lunar calendar? 2. How does the length of the lunar calendar compare to the length of the solar calendar? Why? I hope you've enjoyed learning about lunar calendars. Thank you. Bye.
All right, so that was a very insightful presentation by Dr. Alam, and I saw that she put a couple of questions in there just to get our minds get our creative juices flowing. So let's move on to our question now in Kahoot. So let's get our devices ready. All right, so that's our straightforward question. What is a lunar calendar? That was in her presentation as well. So hopefully we all get this answer correctly. All right, good stuff. So the vast majority got it correct. We'll now be hearing from Dr. Martin Connors. Dr. Connors is a professor of space, science, and physics at Athabasca University's Center of Science. He directs the Athabasca University observatories doing astronomical and auroral research. Thanks for joining us today, Dr. Connors.
Yes, I'm very pleased to be with you. Thank you very much for inviting me. I've enjoyed your program so far, and I hope to add a little bit to it, but already you're doing very interesting things, and I'm very happy to see that. So the topic is anyone can be an astronomer, and it looks like some of you already are. But let's start, if you wanted to do something in astronomy, you could go outside tonight, if it's clear, obviously, you can't have clouds in the way. And if you look up and face south and a little bit to the west, after it gets dark, you will see 2 bright planets, and that's at the lower left on the screen. Those are the planets Saturn and Jupiter that you've surely heard about. But if you look higher up, oh, and by the way, if you go out a little bit earlier, you will see the planet Venus after sunset. But by the time it's fully dark, Venus will go away, will set. So if you look up from those planets, you'll see what we call the summer triangle. So the stars you can see change with the seasons, and that reflects the sun moving around. As seen from the Earth, it looks as if the sun moves around the Earth. Of course, the Earth moves around the sun. But in the summer, we see this famous summer triangle, and it's a triangle of very bright stars. And then within the triangle, we have individual constellations. So here are 2 of them. One we call the Northern Cross, but that is not actually a constellation. The actual constellation is called Cygnus the Swan. And then below Cygnus the Swan, we see the constellation of the Eagle. So you can see that the eagle sort of looks like an eagle. And interestingly enough, the Islamic people studied these, and the names of constellations are mostly from Latin, but the names of stars are mostly Arabic. So let's look at some of those. So ancient people looking at the sky made figures there and joined the stars together to make figures that mostly came from mythology or were names of animals. So as I said, most of those astronomical names for constellations are Latin, but most of the stars are Arabic. And I will not try to pronounce the Arabic names. I'm hoping most of you can read them. So if we start with Vega, it turns out that that is also an eagle. So we only have 1 eagle now, but for the Arabic peoples, there were 2 eagles. And then there's the second one, is what we still call the eagle. And the star Altair in the eagle describes the eagle. Now, another interesting fact from the Arabic is that we have Deneb is a very famous bright star. And in fact, Deneb means the tail. And that's because it's the tail of the swan, although in Arabic it was the tail of the chicken. So if we look at other places, there are other tails, interestingly enough. So there's a tail on the dolphin, there's a tail on the goat, which is very near Jupiter right now. And then I don't know why the fox doesn't have a tail designated, nor does the eagle. An interesting star is Arrakis, and there will be a movie out this year that is based on that star, although in fact in the movie and book, it's not really in the place that it really is found. It's further north. So if you do want to get started doing astronomy by just going outside and looking, you need a good guide. And this guide I found when I was in the 4th grade. It was in my school library. And so many of you are in schools, and I encourage you to try and find this book there. It is a little bit hard. It's usually a special order book in a bookstore. It's still my favorite book so many years after grade 4. So just with your naked eye, you can go out and you can see a lot. Now, if you want to see more, and say, for example, the moon, you need binoculars to see it well. If you want to see, as one of the previous presentations said, there are craters, you can see them with binoculars. You do need real binoculars. Opera glasses, so-called, which are very small, generally are not as good. And also, you can take photographs with almost any camera. The most important thing is to have a tripod, because you need to take the photographs for a few seconds at least, and a person cannot hold a camera still for that long. So a tripod, and you can even use an iPhone, and you can put it on a tripod with an adapter. So an ordinary camera will screw right onto a tripod. For an iPhone, you need an adapter. Another thing that was shown already in the presentations is the use of the iPhone to actually hold up and show you what stars you're pointing at. So this shows the bottom part of what I showed earlier on is visible, and it's a little bit blurry because I didn't use a tripod for this. And so you can maybe see Jupiter is there, and the constellation of the Goat. So another important point is that Canada, you can't really do free advertising, but Canada has an amazing astronomy society. So this is just my personal opinion. It's called the RASC, rasc.ca. They will work with schools, but if you want to become more advanced in astronomy, going to the people in this, and you don't even have to join. You can go to their meetings, you can go to their events. And so I would highly recommend our amazing astronomy society. I became a member when I was 17 years old and still am a member. So this is something Canada has that, for example, the United States does not have. So please, if you're interested in going further, be aware that Canada is very well set up, and the little yellow dots indicate where all the local branches are. In Ontario, where most of you are, you have a huge choice of places to join or just take part in the activities without joining for the RASC. Now, what if you want to become an advanced amateur astronomer and take beautiful photos like this one taken by my friend? Well, you do need to then get into a telescope, and possibly quite an advanced telescope. And so as the writer, who also has some good books that you will find in the bookstores easily, Alan Dyer says, the best telescope is one that gets used. So if you buy a telescope, please use it. You'll be amazed at what you see. However, be aware that you can get into this trying to buy a better telescope, a better camera, and it can be very expensive. So if you're getting into this in a serious way, you're going to pay for it, but you will get excellent results like my friend did. Now, if you want to become a professional astronomer, I've borrowed some things from the United States, but the situation is much the same here in Canada. First, you have to go to high school, of course, and so you need to do all the science subjects, possibly not biology, although if you're interested in extraterrestrial biology, that might be a good idea too. Then in college, you have to do all the science subjects and math and chemistry, they don't mention computing, that's also a good thing to do. And you pay for all of this yourself. Hopefully you can get a scholarship and that will help. However, when you get to graduate school, which again, you need years of study, they do pay you. Not very much, but they pay you and that's helpful. So once you become graduated, you do postgraduate work, which is not very well paid, but it lets you at least get a foothold and do research. Then there are various categories shown in blue of postdoctoral appointments, and then in purple if you continue on. So at the bottom it says the important thing, 22 years after high school, you may have a job. So this is a lifetime commitment to really be a professional astronomer. So what do astronomers not do? You did see that the Islamic astronomers, when they were consulted by a leader, they could do horoscopes. This is not something we do anymore. They do not have a special connection. So there's a horoscope. They do not have a special connection to space aliens. Some of us don't even know the constellations, and virtually nobody spends all their time looking through a telescope. It's mostly done by computer. And unfortunately, the telescopes are in Hawaii and it's nice to go there. We generally don't. We put in a request and somebody else does it. So a typical day is being very, very busy and often with things that have not very much to do with astronomy, but all of these things have to be taken in course. And so Canadian things, there are 565 members of the Canadian Astronomical Society. I mentioned the Royal Astronomical Society before, and that is amateur astronomers. The Canadian is the professional astronomers, 565 of them. It's about the same number as the members of the House of Commons. So it's not a common thing. I'm not sure if people can see this thing that popped up. And in fact, I also got my shukran somehow in there. So many people who train in astronomy have to go to the United States or other countries because there are not really that many in Canada. However, astronomy training is excellent for other careers. If you're an employer and you want to get a computer person and an astronomer walks in the door, they said, I've done all these studies in astronomy, don't say, well, that doesn't mean anything to me, because they're going to know a lot about other things, including computers and possibly electronics. As I mentioned, you have to wait 22 years or so. Once you wait, you get a big salary, but it's a long wait and you may not be well paid at that time. So with that, for some reason, I cannot click to my thank you slide there. So I'm aware that the grammar in Arabic may be slightly incorrect, but shukran.
Perfect. Thank you, Dr. Connors, for that intriguing presentation on astronomy. And I think you gave especially important insights, especially for those who are interested in pursuing a career in astronomy. So now let's move on for our next Kahoot question. Here's the question. As a child, what book captured Dr. Connors' fascination? Was it Curious George by H.A. Rey? Was it Harry Potter by J.K. Rowling? Or was it The Stars by H.A. Rey? Perfect. Yeah, most of us got the answer correctly. All right, so our final presentation is a video on the Aga Khan Museum, which houses several intriguing ancient artifacts. And it seems that we may go a few minutes over 11:30, but just bear with us. This is the final presentation, and then we'll be wrapping up, and we'll be announcing the winners of the Kahoot as well.
Good morning, Michael.
Good morning.
How's it been?
Very, very well. Very well.
Great. So
Yeah.
what do you do at the Aga Khan Museum?
Well, my role here is as curator. So I'm one of 3 curators on staff, and our ultimate goal really is to be caretakers of the collection. When we say caretakers, we mean in a physical sense, for sure, but we also mean in the sense of being able to interpret this material for audiences who come to visit us.
Okay, that's interesting. So when you get these objects, are you the ones who date them?
Well, the collection is actually based on the collection of Prince Sadruddin Aga Khan, who is the uncle of the current Aga Khan. Prince Sadruddin died in 2004 and left his collection as the foundational collection for the museum. When we do receive objects, when we acquire objects additionally in the museum, yes, we certainly do the research and date them and provide all of the facts about those objects. But we knew so much about the collection already when it entered, when we opened the museum in 2014.
Right.
Yeah.
Right. So, as you know, we've come here specifically to study more about astronomy-related artifacts that you might have in your collection. So, would you start us off with one and
Sure.
tell us more about it?
Absolutely.
In particular, the historical background, as well as how does that piece of work fit in and contribute towards modern astronomy?
Toward modern astronomy, great. Well, what we're looking at here is a manuscript. It's a book, and literally a manuscript means something that is handwritten. So it's a handwritten book that was produced in Iran in the 17th century, in the mid-17th century. However, the manuscript contains a text that was written in the 10th century by an astronomer, a scientist named Al-Sufi. Al-Sufi was a scientist. He was an observational astronomer, and what his goal was to observe the stars in the heavens and to calculate their positions in the sky based on old knowledge from ancient Greece, particularly from the works of Ptolemy, and to synthesize that, to link it up somehow with pre-Islamic Arabian knowledge of the stars. So there was a science or a study of the stars in pre-Islamic Arabia known as Anwa. So here we can see a copy of Al-Sufi's text, which is known as the Book of Fixed Stars. It was the text itself was written in Arabic in the 10th century, in the year 964. But it was copied many, many times and translated, in fact, many times. What we see in this particular manuscript are illustrations of a constellation that contain Arabic text near it that describe the stars, and then a Persian translation of Al-Sufi's text in the margins all around. That's the writing that you see all around. Now, you'll notice in this manuscript that each of the constellations, these are the fixed stars as opposed to the planets, which are unfixed. They move in the sky when we look at them. The fixed stars, these constellations, are shown in mirror image. You can see one on one end and one on the other. They're actually the same constellation, just oriented in opposite directions. And the reason for that is because Al-Sufi wanted he wanted his text to be a teaching tool. He wanted people to look up at the sky and see the constellations and be able to correlate it to the manuscript. At the same time that people were looking at the stars, one of the tools that they used a long time ago was something called a celestial globe, which we have an example here. It's like a globe, like we would normally be familiar with, but instead of showing the land masses of the Earth and the oceans on the surface, what it is the constellations and other heavenly bodies in the sky taken out and then wrapped around a globe form. So basically it's a mirror image of what we see in the sky. So this way, illustrated copies of Sufi's text show both what we see in the sky and what you would see on a celestial globe, the mirror image. That way it's much easier to study and make the direct correlations between the tool that you use and what you actually see in the sky. There was just a general interest in the stars and in the heavenly bodies, and really in the scientific knowledge that was initially developed in other parts of the world, like ancient Greece, ancient India, and so forth. There was a general interest in the Islamic world at this time in taking that knowledge, translating it into Arabic, and assimilating it, making it part of the broader field of knowledge that this part of the world had. And it was with this old knowledge that's then assimilated. Another thing that Al-Sufi did is recalculate and discover new stars. So he recalculated the positions, he discovered new stars. There was a lot of new scientific knowledge that came with his study of old texts and with the development of his own text on the fixed stars. So this is part of a broader movement at the time known as the translation movement, which was sponsored by the Abbasid Caliphate, to translate knowledge from other parts of the world, assimilate it into the Islamic world, and then to use that as a building block to keep building more and more and more knowledge. So for our contemporary day, what's important about this manuscript is it's one of the earliest examples of true observational astronomy. It shows an impulse to getting it right, not just sort of looking at pictures of forms in the sky. It was really about scientific knowledge. And it's something that the text was copied again and again, translated into Latin. It was really the basis of astronomical knowledge for centuries. And it's with this text that we really have the development, the building blocks of modern astronomy.
Wow, that's wonderful.
Okay.
So did Al-Sufi also invent some instruments to do this, other than the one that you just mentioned?
He was an inventor, but he was also very interested in a tool known as the astrolabe. And we're going to look at an astrolabe in a moment. An astrolabe is, again, a development of the ancient Greek world and of ancient Greek knowledge, but it was really perfected under Muslim scientists. Al-Sufi wrote a treatise on the astrolabe and describes over 1,000 uses of this instrument, how it can be used. So let's have a look at an astrolabe in the collection.
So Michael, you were telling us about astrolabe, and I guess we have one right on hand.
We have one right on hand. We have a very important astrolabe right on hand. So an astrolabe is this instrument, a very elaborate instrument that is of flattened shape and has various dials and discs attached to the surface. And the purpose of these instruments is to be able to hold them up. There's a ring at the top that you can hold up and position the dials that have indicators. Position the dials in a way that you can align them with what you see in the sky and therefore understand where your location is on Earth. So it's a really interesting calculating tool. It was developed in ancient Greece as a sort of tool, but really it became very important in the Islamic world because of the need to understand two things. One, navigation by sea, and also navigation across land, since there was so much mercantile activity from the inception of Islam all the way through even the present day. But before having GPS locators on our phone, we needed to use other rudimentary instruments, and here we have a very beautiful example. The other was to determine one's location so that one could perform ritual prayers at the right time of day, in the right direction, praying toward Qibla, and so on. And so this tool could be used in that regard. If you're, let's say, in the middle of the sea, or you're in the middle of the desert, or in the middle of the mountains, and you have nothing to indicate where you are, this would help determine all sorts of ritual times that were significant for the practice of the faith. And so we have very elaborate instruments of these astrolabes that are developed. They often contain a series of discs inside of them. So you can actually unscrew the indicators on the surface and use the different discs depending on roughly where you are in the world. And this astrolabe, which was produced in Spain in the 14th century, this astrolabe contains 4 discs. And one is a disc that tells you your location in Nantes, France. One is in, I believe, in Toledo in Spain. One is Jerusalem, and one is Algiers.
All right, that was quite an interesting video. It's truly remarkable to see the kind of artifact collection that are housed at the Aga Khan Museum. So now, as promised, we're going to head to our final Kahoot question. What is a constellation made of? Moving stars, fixed planets, or fixed stars? All right, most of our people correctly answered fixed stars. Perfect. So here are our winners. The third place is Ethan Lam Jashmiga is second place, and first place is Leah M. or Liam. I'm not sure how to pronounce that, but congratulations to all three of our winners here. And I would just request for the three winners here to please email us at info@islamicheritagemonth.org. Once again, that's info@islamicheritagemonth.org to collect your awards and your prizes. And that's just for the three winners. So that concludes our program. I'd like to thank all of the presenters and participants for joining us today. We hope that during this Islamic Heritage Month event, you're able to learn about the vast contributions of Muslims to the field of science. I'd also encourage the teachers to provide your feedback on this event via the link which was sent to your email. And just to note that the videos you saw here today will be available on our website, which is www.islamicheritagemonth.org. And at this point, I'm going to pass it over to my colleague, Kira.
Thank you so much. Assalamu alaikum, everyone. My name is Hira Islam, and I am the content director of the Islamic Heritage event. I truly hope that you liked our program today. We are now going to open the floor to take up some questions you might have. If you would like to ask, please use the Google spreadsheet link that was emailed to you earlier. So we have received around 5 questions already, actually 4 questions, and most are to do with the Aga Khan Museum. So I'm going to refer them to agakhanmuseum.org. That's their website, and that's exactly where you can get the exact address for the museum. The museum is located on Don Valley Parkway, so it is downtown Toronto. As far as the other questions are concerned, let me read them and then read up a paragraph from the Aga Khan Museum's website. So they're asking, where do they get the artifacts from? How did they find out the year the books were written in? And how are they kept in such good condition since they are so old, the books? So I'll read this passage from the Aga Khan Museum. I think it explains all these questions. So the website says, the Aga Khan Museum presents and collects art from historically significant Muslim civilizations, as well as contemporary Muslim communities and diasporas around the world. The core of its permanent collection, spanning a vast geographic area from Spain and North Africa in the west, and across Middle East to South Asia and China in the east, was assembled by Prince Sadruddin Aga Khan, 1933 to 2003, uncle of His Highness Prince Karim Aga Khan IV. Prince Sadruddin began acquiring works of art in the 1950s while studying at Harvard University. So I think I will leave it here, and I hope that that explains where they get their collections from, mainly, as well as why they're in such good condition. And I think we can end it here because we're not getting any more questions. So thank you so much for these.
That concludes our event. Thank you again, and I hope to see you again soon. Assalamu alaikum. Peace be upon you.